Hello everyone, welcome to Vidyantra. In the series of Python for data science, today we are going to start with the new library that is NumPy. Before learning the NumPy actual coding part, I would like to give you some basic idea why you should learn NumPy. NumPy actually, if I will talk about the definition of the NumPy, it's a scientific numerical calculation library where you will learn about how to do the mathematical calculation on the array. It provides actually n-dimensional, multi-dimensional, you can say multi-dimensional array object where you can perform various operations like doing sorting of the array, doing multiplication within two array, within multiplication of the matrix. If you want to find the eigenvalue or eigenvector of the matrix, if you want to find the input output operation, various operation if you want to apply, you can apply with the help of that NumPy library. Because actually, if I will talk about list and NumPy, both are similar. People will say that if we have already array available in the form of the list, why we are using NumPy as a new library to perform the operations. So I will talk about that also, because Python is performing very slow with the help of list and other data type that is present in the Python. For example, if I will talk about the list or string operations, they are designed in such a way, these data types are designed in such a way that you will having a very lot of time for the computation. That's why people say that Python is a very slow in the case of computation. So the problem is there are so many people who are from the non-tech background, so they don't know how to do the coding. During learning of the coding, Python is very easy language in the terms of syntax I will talk about. So people find it easy in the learning. So what in the 1970s, what they did, they converted they created a library on the basis of C language that is working on the basis of C language, but the syntax is related to Python. So the performance will be like a C language, very fast, and the syntax will be also very easy at the same time. So that's why people find it very easy to learn NumPy, and we are learning NumPy in the for the doing any project of the data science. So I will like to tell you that NumPy and list both are similar, but in the case of NumPy, you can save only one type of data at a time. For example, if you are saving a data of integer, in that case, all the data will be of integer data type. But if you are creating a data at the start string, so all the data will be in the string type. So similarly, you can say array and list both are different, because they firstly array is static, you need to create the size. But in the case of list, I have already explained that in the case of the list, if the size is filled, you will get the double size at the ram and at the another place, and you will do so on. So in the case of dynamic array, your length are variable, but in the case of static array, you will have a fixed size during the defined time, and the array having a fixed size. So in the terms of array and list, they are also different in the terms of static and dynamic. This was the basic part that you should know as a theory of the NumPy. There are so many more theories that you should learn. You can do the Google for that also. But now moving towards the practical part, if I will tell you to use the NumPy, what you have to do, firstly you need to install the NumPy library. For that you need to write the simple command pip install, just simple command pip install NumPy. By this you can, if you have already installed it in your system, it will be saying that requirement is already satisfied. If you have not installed in your system, then you can simply install it by using pip install NumPy. But if you have installed it earlier, I have already told that for any library you don't need to install it again and again in every file. But for using that, you need to import that file every time, right? For that, what you need to write, you just need to write import numpy as np. Why NP? NP is, you can say that it's a nickname. Writing the full name NumPy again and again will have a spelling mistake, so I am calling it as a NP. Now, if I will talk about creating an array of NumPy, what you need to do, you just need to pass an list. So I'm taking a list 1, 2, 3, 4, and 5. It's just a number, random number I am taking for creating the array. What you need to do, there is a method in the class NumPy. So I am calling now NumPy as NP. So object of NP dot, the method that is available for converting it into the array will be array. So NP dot array, and I have to pass the list that I have created for converting into the array. If I will run it, you will see that now your array is created having the items that were in your list. You can also assign it into the new variable like arr equals to np dot array li, right? So this is the NumPy array that you have created. So if talking about the data type, which data type I should take, so you can take the data inside the list, or you can also take the data inside the tuple. For example, I am taking the data inside the tuple. So I can take li equals to 1 comma 2 comma 3 comma 4 comma 5 comma 6. Now I have taken a tuple of item and I am trying to convert it into the array of NumPy. So what I will do, I will just pass that into the np.array method. So you can see there is no any error while creating the array of NumPy array of tuple item. So you can also say that during the creation you can also use a tuple. What if I will use the set? Is it possible to create a set data type into the array? Let's see. So if I will convert np.array of L1, so if I am getting the array, then it will not having any array. You can see that 1 2 3 4 5 6 has been converted into the array, and you are showing no error. So if you want to assign the data type also, you can assign here during the passing of your array. For example, if you will see here what I'm getting 1 2 3 4 5 6, which is nothing but the integer value. In case if I want the data type to be a float value, in that case I will write d type equals to float. If I will run it, you can see that you are getting 1.2.3.4 like this. So at the time of creating the NumPy array, you can also define the type of data that you want inside your array. Okay, so this is how you can create any NumPy array with the help of a very simple method, that is NumPy.array. Now there is one more method available, that is arrange. You can say there is a method like arrange. It's similar to the sequence that you were using during the loop. For example, for I in range this, so you are getting the range of the item. Similarly, I can create an array of by using the arrange method. np.arrange arrange, you can say array of your range that you are giving. For example, I am giving the range from 1 to 10. In that case, you will get an array where there will be an item from 1 to 9, just like range, and you will having an array of that, and you can assign that inside any variable like this. So with the help of arrange, you can also create an array. And there is one more method that is available for creating the array, that is as array. For example, if I am taking any list 1 2 3 4 5 comma 6 like this, if I want to convert this into the array, there is a method np.array. With the help of that, I can convert that into the array, right? So you can say that your array is now list is now converted into the array with the help of array method. So we have seen three methods for creating the NumPy array, that is the array. Second one is the arrange, and third one is the as array for the creation of your NumPy array. If I will talk more about the data type, in that case how you can say that it's an NumPy array. For that, you can simply print the type of the array that you have created. For example, I have created the array and store into the variable arr, so I can check the type of arr by just using the function type. Here you can say that numpy dot nd array that you have been created. Now moving further, if I will talk more about the data type that I had given here. So what are the types that are available? For example, sir, if I will copy the same code here and use the d type function that is available for converting it into the array. So I will type here as d type equals to float. So our data type will be in the form of float, you can see. Now if I will use, instead of float, if I have used the complex, means for the integer you can use simply int that is already present in your uh, list, that is 1 2 3 4 is nothing but the integer only. If I will take int complex in place of int, so in that case you can see that your array is in the form of 1 plus 0j, 2 plus 0j, that imaginary part is 0, you can see. But your array have been created with the uh, complex values, right? Complex data type. And one more data type that is available, you can say, you can write here bool instead of complex. So if I will run it, you can say that all the value are showing true, means python takes all the value, non-zero value as true and zero value as a false. So bool data type is also available for giving it as a type of your data, means the array you are creating, right? This is how you can use the d type function available. Now moving to further, if I will tell you that not only the array you can create, you can also create the n dimensional array. For example, if I want to create the matrix, means for example I want to create a 2 cross 2 matrix. In that case, what I will do, I will take two list. One I have already taken, like li equals to 1 2 3 4 5. Here your first row will be 1 2 3 4 5, and I am taking the second list as 2 3 4 5 and 6. This is your second list or second array, or third array you can also take. Now if I will convert it into the array, what I need to do, I need to write np dot array. Np dot array, what I will pass it, li comma li comma l1, right? Li comma l1. Now if I will run it, there it will show like error that you have passed the two array and you are creating the 1d array. Means if you will talk about the matrix, in that case we have number of row and a column, right? So it's a two-dimensional array, two-dimensional data, means you can call it as a tensor. What is tensor, that we will discuss in the next video, in another video, because tensor is a very big topic to learn. But if I will say it's a two-dimensional, means I need to also pass it inside the list. So if I will run it, now you can see that you are getting a matrix. So in this matrix you having a 2 row and a 5 columns. So this you can say with the help of numpy array we can also create a n dimensional array, n dimensional tensor, you can say. For example, if you want to create a matrix 2 cross 2, right? So in that case what we can do, there is a method available called reshape. Means for example, sir, if I want to create an array of, you can say arr equals to np dot arrange method, there is arrange method available. I want to create the array from 1 to 13, means there will be a total 12 item available. In that case, what I can do, I can use the reshape method. Reshape method is there where you can change the shape of your array. For example, in this case your array will be having a 1 row and 12 columns, but if you want to change the shape, you can take right as 4 comma 3. Means now the array that you are created arr, that will having a 4 row and a 3 column. You can see in this array we are having a 4 rows and 3 columns. So by using just reshape method, you can also reshape your array that you have created. For example, sir, if I am writing here I am having a 12 number of items in my array arr, but I am writing the shape here 5 cross 5. Will it be possible? Because 5 cross 5 requires 25 items, right? But I am passing only the 12 items inside my array, so it will not be possible to convert it into the 5 cross 5 matrix. But instead of 4 cross 3, I can write 3 cross 4. Why? Because 3 cross 4 will having a 3 number of row and 4 number of columns. You can write any multiple of 12 like 6 comma 2, 2 comma 6. All the shape that are multiplying together will give the shape of that your array. Number of the item inside your array can be reshaped, right? So with the help of reshape method, you can easily convert your array into the shape that you want, right? Now moving further, if I want to create an array of the item having all the zero value. For example, if I am having any data, there are so many rows available, but I want to create one more column that is having all the value as zero. Why we are taking the value as zero, why we are taking the value as one? We You will learn that thing deep during the learning of neural network, because you know that during the sign of the weights we need to create the matrix of the uh, one item are there, right? So in that case, you will be required to creating the array having one item. For example, if you want to create a array with zeros item, so you what you can do, you can type the variable name 0 and just use the NumPy.0 method that is available for creating the array with the item 0, and you can print that 0, and you can see that all the items that are present in 0 are all the items are 0. That is used for the initialization purpose. But if I will talk about creating the identity matrix, means we have learned how to create the matrix, right? Now if I will talk about creating the identity matrix, so there is a method np.I which is available for creating the dimension of the. For example, if I want 2 cross 2 matrix with identity having a diagonal value as 1, what you can do, just you can pass np.I. Now you can see there is 2 row and 2 columns and all the diagonal value are 1. So we have created a identity matrix of element having 0, right? Now if I will say to create you that matrix of 5 cross 5 having all the values as 0, so that we had used the method np.0, right? So instead of passing only single dimension, what I will do, I will pass a tuple of 2 dimension. For example, np dot zeros, and I will pass the tuple 5 comma 5. Here with the help of this, what you can do, you can create the numpy array having all the values as 0, right? Having a 5 cross 5 dimension and all the values are 0, right? Now there is a one more method available for creating the array, that is a linspace. Means linspace means linearly spaced. Means if I want to create an array, you can say I want an array of 1 to 20, and all the items. For example, I want 10 number of items, so I will pass the number of items that I want, but all the items that will be created array having a uniquely spaced. Means the second value, you can see this is the second value and this is the first value. So the difference between this and this will be similar as similar if I will compare the difference between this third and second, and if I will compare fourth with third, all the next item n plus 1 minus n will have a equal number of equal distance in the case of linspace, right? So if you have created a 10 items, right? If I will tell you that there is 10 item, if I want to reshape it, I can reshape it with the help of my reshape function, and I can reshape it into 2 cross 5 because there are 5 number of 10 number of items, and 5 cross 2 is nothing but a 10. You can see that you have 2 rows and 5 columns that are available in your reshaped array that you have created, right? So this is the things that you have used for creating the identity matrix or zero matrix for creating an array. If I will tell you that, sir, I want to initialize a weight not 0, I want to initialize the 1. If I will write the code from the scratch for that, so it will require more number of lines for writing the code, and as a data scientist you don't need to waste your time during these things, right? So there is a method available like np dot once method is available. with the help of which you just need to pass the size. For example, if I will pass the size like 5, so you will get an array having all the item as 1. But if I will pass the size as in the form of tuples, so I am passing the tuple size as 5 cross 5 and just closing these functions. So you can see that you have got the matrix of 5 cross 5 and having all the item as 1 1 1, right? I think you got how to create the matrix of the things, right? Any dimension matrix that you want, you can create, and you can also say this matrix as a 2D tensor. What are they? Those 2D tensor and all. I will explain you in any of my video. You can see that. If I will talk more about the I method that we had used for creating the matrix with diagonal element as 1. So for example, if I want to create a matrix of dimension having 4 rows and 5 columns, so is it possible to create the identity matrix with 4 cross 5? No, because we know that identity matrix is a square matrix, but 4 cross 5 is not a square matrix. So the method I is creating the matrix with dimension 4 cross 5 means you can also create a rectangular matrix or any other dimension matrix, right? So if I want to create the identity matrix specifically, in that case, one method is available, that is NumPy dot identity. That identity method that is present in NumPy is used to create the matrix of identity, that is 1 5 cross 5, right? Square matrix will be there. If I will pass here 5 cross 4, so it will produce an error that you cannot convert it into the rectangular matrix, right? So if you want to create a identity matrix, so in that case you need to write the only the single dimension that you want 5 cross 5 or 4 cross 4, right? So if I will move further, for example, I want to create an you can say np dot linspace. I want to create an array having total 27 item, you can say, right? And I want to reshape it into the dimension, you can say 3 cross 3 cross 3. It means that you have created a matrix where all the matrix is having a 3 cross 3 dimension and the number of items that is present in your matrix is 3, right? So this is nothing but a 3D tensor. Means what is the tensor? You can say this by combination of the 3 cross 3 matrix, you have created a 3D tensor where all the 27 items are present. We are going to discuss about what is indexing and slicing. Indexing means whenever you want to find out any particular position value. For example, in the case of list, we were doing that if I want to find the 0th position or a first position value, we were doing the indexing. Similarly, there is indexing and slicing in array. For example, we have created an array with the name ARR. In my ARR array, we have 2 rows and 3 rows and 4 columns. If I want to find out only the 0th row, in that case what I will do, I will use the square bracket and pass the index which row I want. So I have passed the 0th row, that's why I am getting the 0th row value. You can see that 1 2 3 4 and our 0th row value is 1 2 3 4. This is called the indexing. By this you can find out any particular, for example, you want 0th row and the first position value. 0th row first position value will be, this is 0th row and 0 1 first column, right? So the output should be 2. If I will run it, you can see that we are getting an output as 2. Indexing means if we want to find out any particular value like 0 comma 1 at particular I comma j, or I want whole ith row, I want whole ith column. In that case what we will do, we'll do indexing. Now talking more about the slicing. Slicing is like you are slicing the piece of material, right? If I will talk in the general term, you slice the mango, right? So slicing a mango means you are cutting a part of the mango. Similarly, in the case of array, I am finding the some part of my array. For example, if I want to find out the 0th row, from I want a row from 0 to 3, means I have a 3 row but I want a row only two row. So what I will do, I want 0th row and the first row, so I will stop at second row. And what I want a number of column only there is 4 column, but I want only 2 column to show. So I want column from 0 to 2, means 0 1 row and 0 1 column. If I will run it, you will see that I am getting a value 1 2 5 and 6, means only this part is getting sliced by using this syntax, right? The syntax is very simple. The first part before comma is the for the rows purpose, and the second part is for the column purpose. Means if you are writing here 0, it will be start from the 0 row, and if you are writing it 2, so it will end at -1 position. Means if it is 2, it will end at first position, means the row will be 0 and 1. If I will go for similar for column, so column will start from 0th column and end at first column, right? So similar way, if I want to print whole of my matrix, in that case what I will do, by default if you use this colon and write the comma, and again you will use the colon and close the bracket. So if you are not entering any of the number here, so by default the start will be from the 0th, and end will be equals to the length of your shape of your array, right? Similarly, in the case of column, if you have not written any start position, so it will be taken as 0, and end will be the maximum number of column you have. If I will run it, you can see you will get the same output as we were getting in the by running ARR. Here you will see that after running the ARR we were getting this output, and similarly I am getting the output in this. So this is indexing and slicing. Indexing means finding a particular position value, and slicing means slicing a part of matrix or a part of array. Now if I will talk about the attributes of the array, means for example you have created any array, like you can assign it in the array name, right? ARRA1, array1, right? Now I have assigned it into the array1, and I want to use the attributes that are available in your NumPy array. So in that case you can use print array1 dot shape. What array1 dot shape will do, it will print the, sorry, it's not callable, it's actually method. So what it will do, you can just write the shape. So array1 dot shape, what it will do, it will give the shape of your array that has available. For example, here you have reshaped it into the 3 cross 3 comma 3 comma 3, right? So the shape you are getting with the help of the shape attribute is nothing but a array dot shape. Why I have removed this bracket, this one, because this is the attribute of the array, and the method is callable, not the attribute. So that's why I have removed the tuple part. Now if I want to go further for the next attribute, that is dimension. So if I will want to print what is the dimension of my array, so in that case you need to print just ndim. What it will do, it will do the dimension of, like I was saying, it is nothing but a 3D tensor, right? So it's saying that it's a three dimension. Now moving further for the next attribute, what you can do, print array1 dot the size that you want to check, right? For example, if I will print array1 dot size, so you can see the size attribute, what it's doing, it's calculating the number of items that is present inside array1 that you have created. So size will return the number of items that is present in your array, right? So if I will talk about the next attribute of the array, so it will be array1 dot d type, that we had used during the creation, right? So we were passing one attribute like d type as integer and all. So you can see the array having a float 64 d type that is present in your array. All the items are of float 64 data type, right? Now if I will talk about the item size, so what we will do, we will print arra1 dot the item size method, attribute available in your array, right? So similar to the type that you were using, right? You were using the you are getting the type float 64 that by using the attribute dtype. Similarly, for checking the every item size, you can use the item size attribute that is present in your array, right? Now uh, you can calculate by these functions, by this attribute you can calculate the attributes that are present in your array. Now talking about the random function, there is a random function available in your NumPy with the help of which you can create a array with the random number like random.rand, that is one method available in which you just need to pass the size of your array, by which you can get that you are getting the array of 5 items that is having a random value that is 5. So one means it's just nothing but the random value. So if you want to pass like more size, like if I want to pass the size of 5 cross 5, will it be possible to create the matrix of 5 cross 5? Let's see. So random dot rand 5 cross 5 comma 5. So if I will run it, you can see that you have got a random array of 5 cross 5 in which all the value are randomly generated, right? This is how you can use the rand function to generate the random integer. Similarly, there is one more method available, that is np.random.rand n. In that case, if I will write the shape here np.random.rand n, you can see that the value you have got are 2 and it is of having a negative value, right? So is it that random n will calculate the negative value? Let's see by changing the size. I am changing it into the 5 cross 5. So you can see that some of the value are positive and some of the value are negative. So what is the difference between rand and rand n? So we will see that, and let's see one more method, that is np.random.randint. This is one more method that is available in your random function. So in the randint function, what you can do, you can pass it like I want 100 items. For example, I want 100 items. If I will run it, it will generate the item from 1 to 100, only single item. So if I want more size, so more items, so what I will do, I will give the range that I want the random integer value between 1 to 100, and the number of items that should be will be 25. So if I will run it, you can say that a random integer have been generated with the value number of item as 25. Now you can reshape it like dot reshape into the 5 cross 5. So if I will run it, you will get a matrix of 5 cross 5. Is it possible to pass the size inside the random.randint function only without reshaping it? Can we do create the matrix of size 5 cross 5 without reshaping it? So in that case, what you need to do, you just need to write np.random.rand int, np.random.randint, and you need to pass the range from where to where you want your random integers, and here you need to pass the size of your for example, I want 3 cross 3 matrix, right? So I will pass the size here, and you can see that we are getting a matrix of 3 cross 3 and having all the random integers. So if you can see, all the value that are generated by using the random function are random generated. So if I will run it, here you are seeing that 0.4915 is the first value. If I will run it again, so you can see that your value have been changed, right? In that case, for example, let's see if I will copy all the codes in a single cell for better understanding, so that you can see we are getting different values at every running time, right? So if I will take one for rand n and one also for rand int, right? If you can say that if I will run them, we will get a different randomly generated numbers, that may be random integers, rand n generated or rand. So I will like to tell about the difference between rand and rand-n is that in the case of rand, you will get the uniformly distributed number, means the number that are getting generated by using the function random.rand that are uniformly random generated. But in the case of rand-n, the numbers are randomly generated, but they are normally distributed data. Means normal curve means if you will draw that, you will get a normal curve like bell curve. So in the rand n, you will get a random normally distributed data. In the normal random.rand, you will get the uniformly distributed data, right? But in the case of random.rand int, you will get the randomly integer of range you have given 1 to 100, right? So if I will run it, you can see that the number here is 0.023, 0.75, 0.3 and all. If I will run it again, you will see that the number that you had got, firstly it is changed, right? So if you don't want to change your number again and again, so there is a seed method is available in the random. So np dot random dot seed method is available. Here you can pass any number, and if you will run it, you can see that you have got a last matrix. I will compare with the last matrix. It is 98, 19 and 85. First row is 19, 98, 19 and 85. If I will run it again, you can see again you are getting 98, 19 and 85. So np.random.rand seed is available. Np.random.seed method, it is doing nothing but it saving your data for the next run, right? So if you will run it again and again, your number will not be changed by if you will apply np.random.seed. But if you are not applying at every run, your random number will be changed and you will get a random number that are generated, right? Now moving further with different learning different matrix operations. In that case, for example, I am creating a matrix of np dot linspace with you can say between 1 to 11, and I want randomly 9 numbers, and I want to reshape it into the 3 cross 3 matrix, right? So you can see if I will print matrix, I will get a 3 cross 3 matrix, and uh, that having a randomly uniquely spaced number, right? So if I want to get the transpose of the matrix, you can say transpose means converting column into a row, right? So all the, for example, 1, 2.25 and 3.5 is the first row, so it will be converted into the column. So by applying just matrix is your variable where you have stored that values, and dot t stands for transpose. So if you run it, you can see that all the value that were in the column, that is getting converted into the row, and all the row value is getting converted into the column. So you can store it into the matrix 2. So you will have a two matrix 1 and matrix 2, and now we are going to apply all the matrix operations that are available in NumPy that you will use as a data scientist, that we are going to learn. So firstly I will start with the concatenation operation. There is concatenate method that is available in your NumPy with the name concatenate, and in that what you need to do, you just need to pass the concatenate, right? Concatenate, right? So now in that what you need to pass, you need to pass your matrix that you want to concatenate. For example, I want to concatenate matrix and matrix 2, so I will pass matrix and mat2, and you need to pass the axis you want to concatenate. For example, if I will not pass the matrix axis and I will run it, you can see that it is showing that only integer scalar array can be converted to scalar index, right? So for that you need to pass the axis equals to you can pass 0 and 1, and 0 stand for got multiple value for argument axis. Sorry, here one more bracket need to be put, matrix comma matrix 1 comma 2, right? If I will run it, you can see that you have merged your concatenate your matrix and matrix 2. If I will talk about axis equals to 0, it will merge vertically, means your you will see your matrix. First matrix is matrix, right? So 1, 2.53, 4.56 and 7.5. Below that, the transpose of that matrix is concatenated because you are merging on the basis of column. So 0 stand for column and 1 stand for row. If I will copy it again and I will paste it here and just change the axis, instead of 0 I will write here 1. So you can see now your matrix is concatenated on the basis of row. So your first matrix is here and the next matrix is concatenated after your first matrix. So concatenation operation can be applied in your matrix by just writing the concatenate method and passing your matrix inside the tuple and the axis in which you want to merge. And now moving further, there is one more operation of the concatenation that is named with the stack. Means if I want to merge my matrix, for example np dot, I want to stack them horizontally or vertically. For example, I want to merge them in a horizontal way, right? So np dot horizontal stack, I want to apply the stacking in my matrix. So I will use a stack that will do horizontal stacking, and inside that I will pass just matrix comma mat2. And if I will run it, you can see that your matrix have been merged, stacked horizontally, similar to concatenate method. If I will keep axis equals to 1, similarly if I will keep np dot v stack, means vertical stacking. So np dot v stack, that will produce similar output as we had got in concatenate and x is equals to 0. So I will pass a matrix in tuples and matrix mat2 comma, what I need to pass, you just need to close the bracket, and if you will run it, you can see that you are getting the similar output as you had got in concatenate operation, but x is equals to 0. Means if you are setting using concatenation operation and using x is equals to 0, that will nothing but will be equals to the your vertical stacking, right? So these were related to the stacking. For example, if I want to apply the splitting in my matrix, so what we can do, for example, I am storing it in a variable m, and for this I am storing it in a variable n. Okay, if I will run it, so horizontal stacked are stored in n and vertical stacking is stored in m. Now there is one more method. For example, if you have a matrix and you want to split it, these were related to the concatenation and stacking. Now if you want to split your matrix, so NumPy also provide one method for the splitting, that is np dot split. np dot split method, where you just need to pass your matrix. For example, I want to pass my matrix m, and in that case I want to divide this matrix into the two parts. So I will pass the matrix m and I will pass the number of parts I want, right? And in which axis you want to divide. For example, I want to divide it into a you can say column wise, right? So I will pass the axis equals to 0 because 0 stands for column. Here you can say that your vertical stack has been divided into a two matrix, that we are getting the matrix and mat2. It is similar to the output that we had got in matrix and mat2. So splitting is doing nothing but the splitting of your matrix m into the two parts, and the axis is nothing but a 0. 0 stand for row and 1 stand for column. So similar to splitting, if I will keep here 1, for example, I am keeping here 1 and divided into the two parts. So will it be possible to divide into two parts? Let's run. So you can see that it is giving the error because your number of column is 3, and dividing 3 into 2 part, it will be equals to 1.5. So it will not be possible. But if I will pass here n, so in your n, you can see n is divided into, if I will pass n, you can see that if I will divided it into a two part, so there is a 6 number of columns, and if I will divide it into 2, you will get a 3 cross 3, right? So if it is divisible into the two parts, so it can be divided, but if it is not divisible, it cannot be divided. So similar for m, if I will pass m here and divide it into the 3 vertical parts, so will it be divisible? Yes, because 3 can be divided into the 3 equal parts, that is having 1 column and 6 row, right? So this is how you can apply the splitting operation. So if you don't want to apply the split and don't want to write the axis part here, so similar you can write the vertical split, that is np dot split, np dot vertical split, and you just need to pass the, if you are doing the vertical splitting matlab you need to pass the m, right? So if I will pass m here, so what is saying that vertical splitting is missing one, okay, one argument, because how many parts you want to divide your matrix? I want to divide it into the two equal parts. So you can see that your matrix m is divided into the two part vertically. Similar, if you want to do for the horizontal split, you will do split, right? So here you will pass your matrix n, and you want pass, you will pass here 2 for doing the horizontal split. So these were the thing that we were doing for the concatenation and for the uh, splitting purpose, right? Now moving forward with the different matrix operation, like if you want to add your matrix, means I want to add my matrix mat, and I want to add my matrix 1 and you can say mat, right? If I want to run it, so you can say that operand could not be broadcast together with the shape 3 cos 3 and 2 comma 5. Okay, so I think the two are of different shape. Mat 2 is with the similar shape. Okay, so I will write here mat 2, and you can see that you have got the addition of the two matrix. So it will be like that you are applying the using the operators that are available in your mathematics. So by using the operator also you can apply the matrix operation, like if I want to do the division of the two matrix, right? For example, if I will write matrix minus, if I will write here matrix similar to plus, if I will write here matrix minus, in that case you can also do the subtraction by using the mathematical operators. Here you will get the subtraction of the two matrix. And similarly, if you want to do the multiplication of the two matrix, you just need to write the star. But if you will see that the value that is available here is 1, so it is doing nothing but the point-wise multiplication, point-wise addition, point-wise subtraction, means the value of 1 comma 1 of one matrix will be added with the value of 1 comma 1 with the different matrix, second matrix. If I will go for the matrix of 1 comma 2, so you will get the added value of matrix of 1 comma 2 and matrix of second matrix of 1 comma 2. So these mathematical operators are doing nothing but the element wise multiplication or division. You can also do the division of the matrix, like by using the mathematical operator matrix divided by mat 2. So if I will do that, you will get a individual division, element wise division of the matrix with mat 2. So by using the mathematical operator, you can apply the mathematics operation on your two matrix, right? But by going with the methods available in NumPy, right? So there is method called add. So np dot add, by using np dot add you can add two matrix, matrix comma mat 2, right? With the help of this you can see that you are getting output 2 7 12 that you had got with your this simple mathematical operation operator, right? So add method do the same thing that your mathematical operator is doing, but there is one more method that is available, that is called sum. You do not need to confuse between the add method and the sum method, because sum method is used for a single matrix. Here you are passing the two matrix. For example, if I want to use the sum method, I will require to pass the single matrix, right? In this case, you will get the addition of all the elements that are present in matrix, and you will get a single output, that is 54. Means it is returning the sum of all the elements present in your matrix. So matrix is adding the elements of a single matrix only, but the add operator, what it is doing, it is adding the two different matrix and element wise, right? So you don't need to get confused. In the you can similarly you can apply the sum function on the different matrix also, and individually you can also do the addition of np dot sum of mat2, right? Similar, you will get the output, resultant output of both the matrix element sums, right? So if I want to apply the multiplication operation, in that case also you can do the np dot multiply function. You can use np dot multiply, what, matrix comma mat2, because mat2, what it is doing, it is doing the multiplication of the two matrix. So you can see that with the output you had got in matrix star mat2, that it was 110 and 29. So 110 and 29 you are getting, right? So multiply and asterisk operator both are doing the same thing. Similarly, similar to sum, there is method available called prod. So what it do, it do the product of all the elements, all the item present in your single matrix. So by this you will get the matrix of all the item of your one single matrix. So you don't need to get confused, and you also don't need to get confused between the multiplication of multiply, asterisk and dot product, because multiply is doing the element wise, means it is taking the 1 comma 1 position element of matrix and 1 comma 1 position of mat2 and multiplying them together and resulting it at here, right? If I will go for the second position, it is taking the 1 comma 2 position item of matrix and 1 comma 2 position of mat2 and multiplying them together and resultant is 10.6875. But the dot product is something different, because in the dot product what you take the first row of your first matrix and the first column of your second matrix, right? By doing them, multiplying them, you are, and adding them together, you are getting the dot product of the matrix. For the dot product, what you need to write, np dot method is available, where you will pass the matrix and mat2, matrix comma mat2, and resultant will be the dot product of your matrix. Here you can say, you can see that multiplication result is something different and dot product result is something different. This is how you can do the dot product of your matrix. For dot product, you can also do the matrix multiplication, means like np dot mat mul matrix multiplication method that is available, that will also give you the same output that np dot method is giving, right? You can see that 18.3.15, right? Why I'm you, if you are getting, I think you will find it boring ki, sir, I'm doing this thing again and again, so why both methods are different? You can use any of the method you are comfortable. Why we are learning it, in the during the project of data science, you will learn that you will find that NumPy is very important library. As a data science student or as a data scientist, you must be aware with that NumPy library, right? Because during the learning of mathematical models, data science models, you will find that NumPy is working uh, very means important task, running very important task, because it is doing the all the mathematics part very easily. So you will not be wasting your time during doing the mathematical calculation, right? So instead of wasting your time in mathematical calculation, you will use your time for creating something new or creating some new features for a model, right? So this is how your NumPy will save the time. Now moving further, if I want to find the mean of my matrix, so these were the some functions that you need to know. Now moving forward for single matrix operation, if you want to check the median of the matrix, for example, I want to check the median of mean of mat2 matrix, right? So I will write here mat2 dot mean, and I will write here the value, right? You will get the mean of your mat2 matrix is this. What, how mean is getting find? All the element are getting added and it is divisible by the number of elements present in your matrix. Similarly, if you want to find the median of your matrix, what you will do, you will call np dot median, and you just need to pass your mat2, and here you will get the median of your matrix. In this case, mean and median both are same, because I think your data is normally distributed, I think. Now if you want to find the median column wise, like print np dot median of your matrix mat2, and I want that matrix every column we should get the, for example, if 3 cross 3 matrix is there, I should get the median of the first column, median of the second column, and median of the third column. For that, what I need to do, I just need to pass my axis equals to 0, because I have already explained that axis equals to 0 stand for row and axis equals to 0 stand for column. So for column, what you will do, you will just copy all the codes and you will paste it and just change the axis equals to 1. So here you can see that this is the median of your first column, median of your second column, median of your third column, and this is the median of your first row, median of your second row, and median of your third row. These are the operation that we are applying on the single matrix. Initially you had applied till matrix multiplication. What you were doing, you were using two matrix and applying the operation between the matrix. Now we are applying the operations on the single matrix. For example, if you want to find out the standard deviation between the data that are present in your matrix, so what you will do, you will just print the np dot std function. Std function is available for calculating the standard deviation. For example, if I want to find the standard deviation of matrix 2, so I will write np dot std of matrix, right? And similarly, if I want to find the variance of the matrix, in that case np dot var, and I will pass the matrix. Why we are using these methods and what are its use, you will get to know while learning the machine learning and deep learning part. But for now, you should know that these are the methods available for your calculation of standard deviation and the variance part, right? So if you want to find the minimum item of your matrix, so what you will do, you will just print np dot mean of what, the matrix, right? I want to find the minimum item present in my matrix. Here you can say in mat2 you have a minimum item 1, right? Similarly, you can find the maximum item present in your matrix, np dot max of mat2, right? So if you will run it, you are getting that maximum item that is present will be mat2, right? Now talking about the next part, there is a method called argmin and argmax. So np dot argmin of the mat2, and similarly print np dot argmax of mat2, right? So if I will run it, that you will see that you are getting the output as 0 and 8. So it's your homework that you need to tell me that what that 0 represent for argmin and what that 8 represent for argmax, right? You can comment that in the comment section, and you will have to learn also that what is argmin and argmax. That is very simple. And if I will move further, there is a cumulative sum function available. So what it will do, it will find the cumulative sum of your elements that are present. So for that sum method is available, and you need to pass the matrix there, and you will see that you will get the cumulative sum. For example, if I want to find the cumulative product also, for that you just need to write the prod, right? And here you need to pass the matrix 2. If you will run it, you can see that we are getting the cumulative sum as 1, 5.75, 14.25, 16.5. How it is getting calculated? Let me explain you this thing, because I think you people should know what is cumulative sum. So cumulative sum is that first element is written as it is, and the second element is written as the sum of second element and the first element. This is how here written, and the third element is written as the element of the third element, and the sum till now you have got means 8.5 and 5.7, and the next element is 16.5, means the 2.25, and the sum you have got till now means 14.25, it is resulting into 16.5, and so on. Similarly, the product will be there. You have to first element will be as it is, and the second element will be product of second element and the first element, and you will write it here. And for the third element, you will do the multiplication of the third element and the multiplication you have got till now, right? So this is how you have to calculate the cum sum and the cumulative product of the matrix elements, right? Similarly, if we are moving toward the trigonometric operation, if I will tell my experience, I have not used any trigonometric operations during any data science model, but what are the trigonometric functions that are available for learning methods are available that you should know, that are very simple. Np dot sine of what I want to find the sine values of my mat2 elements, right? So if I will run it, so it is giving the sine value of the one, right? If you will see your matrix 1 mat2, so what it is doing, it is finding the sine of 1 and writing it here, sine of 4.75, and you are getting the output as minus 0.99, sine of 8.5, and we are getting the output as 0.79. So similarly, if you want to apply for cos, so what you can write, np dot cos of mat2, and you will get the output, right? Similarly, if I want to get the uh, you can say, if I want to find the exponent, so what you will do, np dot exp of the mat2, right? Similarly, if you want to find the log values, right? So in that case, what you will write, np dot log of mat2. I think you are getting it, that you just need to write the function, the name of the function, and you need to pass the matrix, right? So now moving towards the linear algebra functions that are available for your matrix, like if you want to calculate the determinant of your matrix, if you want to calculate the inverse of your matrix, so what you will do, so for moving further, if I want to calculate the inverse of my matrix, what I will do, in my NumPy library, NumPy class, you can say, there is a inner class called linear algebra, linalg. In the linear algebra class, there is a method available, that is inv, that is helping you to calculate the inverse of your matrix, right? So you can see that you are getting an error, that is saying it's a singular matrix, right? What is singular matrix? You know that you cannot calculate the inverse of your singular matrix, right? So for that, what I will do, I will pass my one more matrix I have created, that is matrix. Let me see, will I be able to calculate the inverse of the matrix or not? Yes. So in that case, you can see that you inverse of the matrix you have got, right? So what is the inverse of the matrix? What is the actual meaning of that? I'm not saying that how you are calculating the matrix. What is the actual meaning of that inverse? You should know that. What is matrix? You should know that. What is the eigenvalue of the matrix? What is the eigenvector of the matrix? It is not related to the calculation. What that result is saying. If you are getting any value, what that does mean. So I will explain you in the linear algebra lecture if I will teach you. So this is how you can calculate the inverse of the matrix. Similarly, if you want to calculate the determinant of your matrix, in that case you just need to call NumPy, and in that you need to call the linear algebra class, and there you need to write just det, that is the method available for calculating the determinant of the matrix, and there you just need to pass the matrix, right? So I was saying that mat2 was giving the singular matrix, right? So is it that singular matrix determinant is 0, right? So let me check for alg dot det of what mat2 that we were getting as it is a singular matrix. You can see that the determinant of your mat2 is 0. That's why you are not getting the inverse of that matrix, right? Now moving toward the calculation of the eigenvalue, you just need to call the NumPy, and there you will call the linear algebra, and there you will call the EIG functions, and here you will pass the matrix, right? And you can see that you are getting the result as tuple. In this tuple, the first part is representing your eigenvalue, and the second part is representing your eigenvector. So if I will tell you that these first tuple, you can say list of the first tuple, here from here to here, this is the eigenvalue. means first eigenvalue, second eigenvalue, and third eigenvalue. And for every eigenvalue you are getting a vector, right? So this is your first eigenvector, this is your second eigenvector, and this is your third eigenvector, right? So if I will write it, I want a zeroth element of my tuple, so you will see that you are getting the eigenvalues, right? If I will again copy it and paste it, and I will write it 1 instead of 0, so you can see that you are getting the 3 eigenvector of your matrix, right? So this is how you will be able to calculate the eigenvalue of your matrix. Now if you want to calculate the single value decomposition, in that case you just need to uh, write a function that is svd. Means there is a function called single value decomposition, and you just need to pass your matrix, and if you will print it, you will get a singular value decomposition for your matrix. What is singular value decomposition? What is the definition of that? You have to uh, write me, right? You have to write me in the comment section. So these were the methods that were necessary to learn in your NumPy library. There are so many methods that are available. If you will Google it, so you will get lots of more methods. But I have taught you only the necessary methods that you should know as a data science student or as a data scientist. So I have taught you only those methods in this video. If you want to learn those also, you can Google it, and you can try with try those functions also, right? So I have told you that already that you cannot learn the coding by just watching the video. You have to do uh, practice by doing yourself, right? So, and I have also told that at end of every video you will get one assignment. So today's assignment is you have to apply all these functions on the matrix you will create randomly, right, by using the random.rand. Okay. And you have to also uh, do one assignment, that there is a solve method available in your linear algebra class, right? Inside NumPy there is a linear algebra, and inside linear algebra there is a method called solve. What is the use of that solve method? You have to write me in the comment section, and you have to use all the functions that I have taught on any matrix and do the assignment, right? So till this you have to do the practice that I have taught, and take my words seriously. You have to do coding practically for learning it, right? So do as much as practice you can do, right? So in the next video uh, we will teach you some new library. Till then, bye bye.